Okay, so now if I pick a problem, let's try this one. I think it will be a very good one. We have a rectangular shaped tank. Okay, let's say you have a rectangular shaped tank. Oops. Let me draw the picture for you, although the picture will not be given all the time. Okay, remember, the picture will not be given all the time. You might need to visualize this in most cases. Okay, so it's my rectangular shaped tank. Okay, and it has a square base. So this base, let me try to draw it. This base in green. Okay, obviously this is my base. This base is a square. Okay, it's square shaped. Oops, sorry. Okay, that means if I draw it separately, it looks like this. It's not that small, but I'm trying to show that it's a square shaped base. Okay, and we have an open top. That means, excuse me, there is no surface here. Okay, it's open. There is no surface here. Okay, now, excuse me, I'm saying that the volume, excuse me, the volume of this is, let's say, let's pick up an easy one. Um, let's say 100 again. Okay, the dimensions will be really small, but I think it should be fine. Um, let's say 100 cubic centimeter. That means the volume, of course, it's the volume is 100 cubic centimeter, and we need to construct the tank of sheet steel. It doesn't really matter though what we're trying to uh, use here as the raw material anyway. Um, Now we need to find the dimensions of the tank that has the minimum surface area. Okay, we're trying to find the dimensions of the tank that has the minimum surface area. Okay, so before we move, before we uh, proceed, any question from the question? I mean, does the question make sense?
Are the sides necessarily square as well?
No, it's
Okay.
it's not really mentioned, so it could be anything. It could be squared. It could be any other rectangular shape. Yeah, that's a good question. Only the base is um, squared. Okay, a square shaped. We don't know anything about the other sides. Okay, all right. So first of all, uh, obviously we're looking for. Let me write it for you. We're looking for the dimensions. That means we're looking for the sides, right? Dimensions which minimize the surface area. Minimize the surface area. Now, it's a cuboidal shaped, right? If you consider it in a three-dimensional, whatever you say, three-dimensional space, uh, we now need to consider all the three dimensions, that is length, width, and height, right? And of course, for this shape, for any object of this shape, we need to know how to calculate the volume and the surface area, right? We also need the surface area. We also need to know the surface area, right? Okay, so it's a tricky one, to be honest, for two cases. First of all, the sides uh, could be different, of different shape. One side could be rectangular, and we already know the base is square shaped. So we have two different shapes to deal with in the same um, for the same object. And of course, the second thing to consider here is it's an open top deck. That means there is no surface at the top. Okay, so that's another thing we need to take care of. Okay, so first of all, if I say that the length, what should I write here? Okay, let me use a red color. Okay, so if I say, forget about this particular problem. Okay, if I say that of any shape, my length is x, width is y, and height is h, can you tell me the volume of it, the formula for the volume of it? It's really important. As I said the last time, you should know the formulas, how to find the volume, how to find the surface area, the perimeters and all that. You need to know all this, okay?
Since it's a square, can't you get rid of y and then it's just x squared times h?
As I said, I'm not really talking about this particular problem now. All I want to know, what is the volume if we have any object of this shape, where the length is x, width is y, and height is h. What happens? What's the volume of that?
Wouldn't you just multiply y by x by h to find volume?
Sorry, x by h, that means x times h?
Yeah, a y times x times h would be volume.
Right, exactly, very good. So the volume of this would be the height times, I should say the length times width times the height. Yeah, you're right. So again, you need to know different formulas, of different objects, because for different shaped objects, the volume will be different. So only memorizing might not be helpful. You need to understand what's going on. Okay, so we know that it's x times y times h if these are the dimensions. But on this occasion, I think someone already pointed it out, and we're going to use it, of course. We know the base is squared shape, right? This base is squared shape. I shouldn't use this. So that means, let's say this is my base. So initially I wrote it like this for general cases, but for my problem, I can actually get rid of this y or x, whichever you think you can do, and replace this by x. If you want to replace this x by y, that's still fine. But these sides are equal, right? Because it's a square. The base is squared shape. We did mention that, right? So if one of the sides is x, the other side has to be x. Or if you say that this side is y, then this side has to be y as well. Whichever you want to do, no problems with that. But these need to be equal. These two sides need to be equal, because that base, this one in white, let me use another color for it. This is my base, okay? It's three-dimensional, that's why it's difficult to visualize, but I have drawn it separately here, okay? Drawn it here separately. Let's imagine that's my base. That's square shape. Excuse me. And if it's a square shape, the sides need to be equal, right? Okay, so now the volume of this would be x squared times h. Do you agree? That's the first thing we need to know. No questions at all? Okay, we can carry on from it from here though. The next thing we need to deal with is the surface area. That's the tricky one, and that's the most important one perhaps. Okay, all right, let's see why is that. Excuse me. So the first question would be, what is the surface area? How do you define a surface area? That's really important, because you'll encounter different shapes. So if you don't know how do we define a surface area, then you might be in trouble. So it's really important to know the stuff first and then go for the particular problem. So what I'm trying to do here again is to generalize the thing, and then we'll go back to this problem. Okay, now for a couple of minutes, forget about this problem. Just try to focus on the surface area of any shape, of any object. Can anyone tell me how to find the surface area? Or how do you define surface area? In general, of course, not for this problem. Anyone?
It's just all of the outside part of a three-dimensional object.
Outside part. Okay, let me take your answer and say that, yeah, we can take the outside part, but how to find it now? This could be the question. I mean, okay, I know that the surface area is the outside part of the object, whatever it is, but now how can I calculate it?
Don't you like find the area of each face and you like add them together?
I couldn't understand because I think my internet was not working fine. Would you please repeat it?
Oh yeah, don't you find like the area of each side and then you like add them together?
Very good. Yeah, exactly. So we can actually find the area of each of the sides. We can find the area of each side, and then we can add those together. This will give us the surface area. Okay, so that's where we need to use the information of the question from the question. So for this particular problem, the first question is, since I said we need to add all the sides, add the area of all the sides, and now the next question would be how many sides do I have, right? Obviously, now I know that if I add the area of all the sides, I'll get the surface area of this object. So the next question would be how many sides do I need to calculate? How many sides do I have, right? So in general, for this type of object, you have 6 sides. Let me show you how. In general, I'm telling you, not for this problem. So this is the first surface, that's surface 1. This is surface 2, okay? And you actually have another one here, right? So this is surface 3. This is surface 4. And the surface which is facing towards you, that means this one in red, the front part of the object. This is surface 5. And you can clearly imagine the back part of it, right? That means it's difficult to show though. This back part is number 6. Okay, let me show it using a real object. Should I pick? Okay, yeah, I think I've got a good one. So for a couple of seconds, I'd like you to see my video, okay? Can you see me?
Yeah.
Okay, so can you see the object I have?
Yeah.
Okay, so this is quite similar to the object we are now calculating. It's actually one of those references you can use for 3-dimensional object. Okay, now I can show you that it has 6 sides. First of all, the side facing you, right? This one. This is side 1, right? And just at the opposite side here, it's side 2. Can you see that? Okay, now the top part, side 3, and obviously the bottom part, side 4, right? And this side is our 5th one, and just at the opposite, we have the 6th one. Do you agree that we have 6 sides? Do you agree?
Yes.
Is there anyone who is still confused? If you are still confused, just pick up anything in front of you, or whatever you have in front of you. Just pick up anything. And if it's not really circular, you'll see it has 6 sides. Just try to, if you are struggling, just try to number those. Okay, start enumerating those, and you'll see that you have actually 6 different sides. Okay, now let's come back to this problem. So now the question would be, how many sides do we have for this problem? Can you locate how many sides you can you need to deal with here?
We have 5 sides
And why?
because the top is open.
Exactly, very good. So since the top is open, that means we don't really need to calculate that upper surface. We don't really have anything there. It's open, right? So we have 5 surfaces to calculate. We need to find the area of 5 surfaces and then add those. Do you agree with this? Okay. Now, let us calculate the surface area one by one. Okay, so let's start with the base. It's a squared shape uh, surface. So what should be the area of it? If I say that one of the sides of the base is x, what's the area of the base?
It'd be x squared.
X squared, very good. So our surface area would be s squared plus, oops, sorry, I should write x squared plus, are we done? No. We have 5 surfaces to calculate. We have only calculated 1, which is the base. We have 4 more here, right? Number 2, number 3, number 5, and number 6. We don't really need to calculate number 1 because it's an open top box, as we said. But we have 4 more surfaces to calculate. Now, how to do that? How to deal with that? What should you do? Let's try this one. Okay, let's try the second surface, one side of the tank. So if I draw this as I'm repeating, but I think I should mention this again, that these graphs, I shouldn't say graph, these pictures, these images might not be provided all the time. So you need to draw this on scratch paper, or you can imagine this. I think drawing would be more convenient. It might take some time, but it will be safe. It will be safer than imagining it or visualizing, trying to visualize it. Trying to visualize it, right? All right. So this is my second surface, okay? This one. And one of the sides is X, another side is H, as I can see it from here. I think I should change it so that you don't get confused. It was for the general case anyway, yeah. So for this side, what should be the area? How can we calculate the area of this side, of this surface, I should say?
X times h.
X times h, because it's a rectangle. And we know for a rectangle, the area is length times width or height, whatever we have. So for this one, we have x times h. Okay. Okay. Now, what if I say the second surface and the third surface should be equal to each other in terms of the area? Do you agree with that? Because, and I can explain why, even if you can't really see why, I can show you mathematically. So for this surface, again, this is the length. I'm trying to highlight it now for you. This is the surface I'm talking about, okay? And clearly, this side is x, right? Because this is one of the sides of the base, and for the base, all the sides are x. So this is definitely x, and this is the height of the tank, right? Which is we know, which is h. We already know that. So again, for this particular surface, it will be x times h. Do you agree? And you can actually see it if you have anything of this shape. The opposite sides will be equal to each other. Do you agree with this? You don't need to trust me. Just try to see what's going on. And as I said, memorizing might be harmful. You need to understand what's going on, because for different problems, you will have different criteria to check. Like this one, we have open top, we have a squared base. This might not be the case all the time. Okay, so you need to know what's going on. So do you agree when I say that the second and the third surface, for both the surfaces, our surface area would be x times h? Do you agree with that? Take your time, okay? This is really interesting, really fun to work with, but at the same time, you need to understand what's going on, okay? You can't really generalize everything for all the problems. For different problems, you need to consider different requirements. Okay, so we'll definitely have 2 times xh, one for this one for this one, right? Let's see the other two surfaces, 5 and 6. So again, if I draw the, the surface pointing towards you or facing you, it looks like this, right? This is the surface facing towards you, okay? So obviously, this part is from the base, and I know that the base has a side x all the time, and this is the height of the tank, it's h. So again, the surface area of this will be x times h. And similarly, if the opposite side, this is the side facing towards you, so the opposite side will also have x times h. If I say that, do you agree with that? Do you agree if I say the opposite side will also have the area x times h? Okay. Now, so I think I should change it to 4x times h, because all the other 4 sides have the surface area x times h, and we have 4 of those, right? Because the base is x squared, the top is open, the other 4 sides has surface area x times h, so we have 4 of those, so it's 4 times x times h. It is the surface area for this particular problem. Any question from this? Any question? No questions at all? Okay. So now we know the volume, we know the surface area. We are looking to find the dimensions which will minimize the surface area. Okay, now let's see if we have anything else to deal with. So again, like the last problem we did yesterday, we actually will build up towards the problem slowly and slowly. Okay, so the question will have several parts, all related to this, but it will have several parts which we'll need to deal with. Okay, all right. So the first thing is, the question might have the first part, write the surface area of the tank in terms of the sides of the square. I mean the base, of course. Here the base is squared, right? So the question might say, write the surface area of the tank in terms of the square base. Okay, so how to deal with that? So we know, or we have considered the sides of the base as x, right? So the question wants us to write the surface area all in terms of x. We don't want any h here, okay? We don't want any h here. Can you see what I'm trying to do here? We have done this before, right? Even yesterday, we have done it. We replaced one of the variables by the other. So we want to get rid of this h and replace it by x. What should we do? You have seen it the last time. Anyone? No one at all? What are the other informations we have which can be helpful?
Would we just do like the same formula as last time, like the 100 times 2x divided by 2?
How did you get 2x?
I don't know. I was just using the formula from yesterday with the area that we did, like 100 times, or not times, 100 minus 2y divided by 2 times y.
Okay,
And
again,
plugging in x instead.
as I said, memorizing would not be helpful. That was the formula for perimeter.
Oh, okay.
And we can't really use it for any problem. We have actually found it for that particular problem. We can't really use it for any problem. So that's why I'm repeating that memorizing will not be helpful. You need to understand what's going on. So if I just quickly go back to that, where is that? Should be here. Yeah, here we go. So we actually use this in terms of x because we know for that problem the perimeter was 100, and we know the definition formula for perimeter. It's 2 times the length and width, of course, whatever you have. So it's 2 times the length plus 2 times the width equals 100, because this 100 was the perimeter and this is the formula for perimeter. We solved this equation for x and then we got this. So this is not a straightforward formula for anything. We actually did it for this particular problem. So we then replace this x into the formula for the surface area, which is x times y. So in place of this x, we use this because our questionnaire wanted us to write it in terms of y. That's why we replaced it for x. We solved it for x and then replaced that into whatever the objective function was. So we'll do it for this particular problem as well. We'll use the formula for the volume, because we know it's been given. Since it's given, we can use this. The volume is given, and we can solve it for a h here and then replace it here in place of this h. That's the trick here. That's why I'm repeating. You need to understand what's going on here. Everyone, I'm talking in general, by the way. So the volume is given, which is 100, and we know that volume for this particular problem, which is x squared h, right? So x squared h is 100. We want to replace this h. We want to replace this h, right? So we want to solve it for h from this equation. So h will be 100 times x squared. Now we can replace this h here. So we can instead write the area is x squared plus 4 times x times for h. We'll write this 100 times x squared. Now does it make sense? Because we wanted to write it in terms of x. In other words, we wanted to get rid of h. In other words, from the known formula or equation, we want to solve it for h and replace that value in the objective function. Any question from this? Take your time, okay? We can, of course, simplify it. So one of these x's would be cancelled, so it will be 400 over x. But this is the value of h, which we have got using the volume, because it's been given. When the question will ask this type of replacement, when the question will ask you to write an equation in terms of a single variable, that means you need to replace the other variable, whatever you have. On this equation, it was h. Yesterday, it was y. No, so yesterday it was x, right? Yeah. So we need to replace that variable. Now, how to do that? Some other informations will be given. For example, yesterday perimeter was given. So we actually replaced or we actually solved it for x and then replaced it. Today, if volume is given, we can use it, solve it for h, and replace it. Take your time, okay? This is not difficult to understand, but it may take some time. Try to understand, try to see why it's done. Then you can ask how it's done, okay? If it's taking some time, don't get demoralized. It may take some time. No worries with that. First of all, does it make sense when I replace this h this way? Again, you can't memorize this because the volume might not be given. Some other things could be given. And then you can use that, solve it for h, and replace your h. So again, memorizing a certain technique might not be helpful. You just need to use the given information and then solve it, whichever you are trying to replace. You just need to solve it for that variable. Like we have done it for h here, we have done it for x the last time. So whenever you see a problem, you can't really write 100 times x squared all the time. It could be something else. You never know. Any question from this? No questions at all? Okay, let's move on. So now we have the objective function a, which we are trying to minimize. Oops, my x is cut off. We're trying to minimize the surface area. We know the expression, we know, I should say function, we know the function finally. Now we can move on. Okay. So the next question could be the interval of interest. We have seen this before as well. Interval of interest is the interval where our solutions would lie. Okay, where our solution would lie. I mean, the solution should not go beyond that. If you try to reiterate this, rephrase it, I should say. And for this one, the dimension could be anything, right? Because it's x squared times h. For the 3 dimension, I think we have 2 dimensions, to be honest, x and h. It could be anything, right? You might say it should not exceed 100. Yeah, you might say that, because whatever you have, any of the dimensions should not exceed 100. You might um, rephrase this, because the volume is 100, so none of the sides should go beyond 100, right? But does it work like this? Let me show you one thing really quick. So what if I say, so x times h, right? So what if I say the base is 0.1, 0.1, so it's 0.01, I believe, right? So for the volume to become 100, what could be the value of h? Can you see that? So h actually could be, or should be, I would say, 10,000. Because if you multiply 0.1 times 0.1 times 10,000, you will get 100. Is it 10,000? Yeah, I think it's 10,000. So that means the volume or the dimensions could be anything. So the interval of interest could be anything from 0 to infinity. Okay. It doesn't necessarily mean that it has to be within 100. Does it make sense? Take your time again. Does it make sense? Do you agree when I say that this height could be 10,000? Any question from this? Am I going too fast? Do you want me to slow down just a little bit?
It's a good pace.
Okay. So now we are finally uh, going to calculate what we are asked to do. That means to find the sides which will minimize the surface area. Okay, now again a quick question. What should you do to find the the sides which will minimize the surface area? Obviously, we haven't used calculus anywhere yet. So you should wonder that there must be some calculus here, right? We've seen this before though. We've seen this the last time. And we have calculated minima and maxima as well, a couple of days back. So what should you do now? Anyone?
Did you find the first derivative of the area equation?
Exactly. So our objective function is this, the area of the surface area of the tank. And we know for finding minima or maxima, we need to find the first derivative, right? So let me write it again. So it's 400 over x. So that means we are trying to find the derivative of this. Now the question would be in terms of what? With respect to which variable? And this time, fortunately, it's easy to see that it's in terms of this x, right? We have only one variable. So dx, the derivative of x squared is 2x. Now what's the derivative of 400 over x? Can anyone do this for me?
Negative 400 over x squared.
Very good. So we can actually rewrite this 400 over x as 400 times x to the negative 1, right? And then using the power rule, we'll get the derivative of this will be negative 400 over x to the negative 2. And we can always rewrite it as this in the opposite order, right? If we can rewrite it this way, so this can be rewritten in this way, right? Just doing it in the opposite direction. So it will be negative 400 over x squared. Do you agree? And you can simplify it just a little bit. So it will be x squared, it will be 2x cubed minus the 400, right? So what's the next thing we need to do? We have already found the first derivative. That's a good thing. What should we do next? We should set this to 0, right? For finding, sorry, it should be x. For finding minima or maxima, we set the first derivative to 0 first, right? And then calculate the values. So 2x cubed minus 400 over x squared is 0. So obviously the numerator will be 0. When a fraction is 0, the numerator is definitely 0. If we solve it for x, it's all algebra though, no calculus here. So x cubed will be 200. So x will be the cubic root of 200. Can anyone calculate it for me? The cubic root of 200? Anyone? It should be close to 14, I believe. 14 point something. Who has done it for me? The cubic root of 200? Anyone? Just use your calculator.
I did it, but I did not get a number close to 14. I got 5.848.
I got the same thing.
Oh, okay, so no, I didn't mean that you have to get close to 14. I thought it should be 4. Oh, it's cube, sorry. For a square, it would have been 14. Sorry about that, yeah. Anyway, if you use your calculator, whatever you get. Yeah, what did you get? 5.848,
848.
okay. Yeah, if it was a square, sorry, my bad, yeah, you would have been close to 14. Anyway, you can trust your calculator more than me, that's for sure. Anyway, so we have found one of the sides, right? We have found x, which is 5.848. So the next thing is to calculate h. And fortunately, we know h equals to 100 over x squared. So we'll just replace it here. X equal to 100 over 5 times 848 squared. Now, what's the final output for h? Anyone? Again, use your calculator. Just divide 100 by the square of the value for x, 5.848.
I got 2.924.
Okay. I can trust you. So 2.924, you said?
Yeah.
Okay. So we can just verify whether it's the right answer or not. So we know the volume is x squared times h. So if you just square this 5.848, square it and multiply it with 2.924, you should get 100. Can you cross check it? Whether or not you get 100?
I got 99.9, so pretty much, yeah.
Yeah, exactly. Because we are dealing with decimals, so it makes sense. Yeah. So that means we are doing it fine. Our answer is right. Now, any question from this? As you can see, the calculus part is really, really small. Just finding this derivative, which is fairly easy. We have done more sophisticated derivatives than this, that's for sure. We have used the product rule, we have used the chain rule for really, really complicated problems. These are actually much, much easier than this, than those. The derivatives of this type of functions are much easier to find, right? So you can see the calculus part is really small here. But overall, you can see algebra, geometry, and calculus, and you need to combine all those to fit the data, whichever fits the data best. You need to use all those resources together in a single problem. That's why it's often tricky, it's often difficult. But obviously together, hopefully we can pull this off, okay? Any question from this? Take your time. I know if you're watching this for the first time, you might be wondering what could be a question. So again, my quick suggestion would be whenever, or rather when you finish, just at the very moment, try at least one problem from the book, okay? If it's a worked out problem, no worries. See the question, hide the solution, see the question, try to solve it. Then cross-check your work. Or pick one from the exercise. I think picking up one from the exercise would not be helpful. Just try one worked out problem. Hide the solution, see the question, try to solve it, and then match it with your work. Then go to the solution. See whether you have done it right or not. Just right after we finish, if you have time, of course, but it will be really helpful. And then you'll see the question will arise. you'll definitely see, you'll definitely find one or two questions. Okay. All right, if you don't have any question right now, we can finally take a break, a breathing break, I would say. So let's meet at 10:22, okay? Let's take a break, refresh your mind, and then we'll start doing something new, okay? See you at 10:22. Let me show how to do it, and then I'll match it with your work, okay? So we know the definition is f of a plus f prime a times x minus a, right? So it should be f of 0 plus f prime of 0 times x minus 0, right? Okay, let us calculate the values, the required values, and then we'll plug it back into the formula. Okay, so the first thing is, let us find the functional value at 0. What's the functional value? Someone from group 1?
4.
4. Very good. Because e to the 0 is 1. So it would be 4. Then let's find the first derivative. What's the first derivative? Someone from the second group?
We got -4 over e to the x.
You're almost right, but not quite. Someone else from group 2? Or did you, I guess, obviously, in the same group, you'll have the same result. Someone from group 3?
We got -4 to e, or -4 e to the negative x.
Negative x, exactly. Yeah. It's -4 e to the negative x. Yeah. I guess the second group missed out on the negative here. Or maybe I heard it wrong. Did I heard it wrong? Did I hear it right? Anyway, so for the first derivative at 0, now what should this be? Anyone from group 4? Group 4? Anyone?
Would that be -4?
-4, exactly. Okay, now we know the value, so we can replace it. So let me take this slightly here, slightly below than it was initially. Okay, so we can replace these values. It will be 4. It will be -4 times x. So it would be 4 minus 4x. Right? How many of you have got the same result? Is there anyone who actually has a different one than this? I might be wrong. You don't need to trust me. Is there anyone who has a different result? Anyone? Okay, so now let me show you one or two more things that could be done to this type of problems. So I might say, or the question might say, hey, can you approximate 4 e to the negative 0.02 for me? Can you approximate this value for me? Or another question might say, hey, can you find this for me? Can you approximate this for me? Obviously, using the linear approximation. The first part of the question will definitely tell you to find the linear approximation like this. And then the second part might tell you that approximate this for me or approximate this for me. What should we do? So that's really easy. So our function was f of x equals to 4e to the negative x, right? Doesn't it look familiar to you? Right? So this is this 4e to the negative 0.2 is basically f of 0.02. Can you see that? Just replace x by 0.02, you'll get this, right? So it will be either this or this. Whichever you have, you are actually doing the same thing. And what to do for that? So this is nothing but whatever format you write, either this or this, whatever you write, this is nothing but this guy. Okay, this is exactly this thing. Oh, I should write this way though. I should do it properly. Yeah, this is nothing but this. And we already know what is L of x, right? So all we need to do is to replace our x by 0.02 in whatever you have for L of x. So it would be 4 minus 4 times 0.02. And if I calculate it, it would be 0.02 times 4, which is 0.08. And 4 minus 0.08 will give us 3.92. So this will be 3.92. This is the answer. Any question from this? So first of all, you need to understand what does this mean. And then we know, or we can use this approximation as the linear approximation. And obviously, in the first part of the question, we have already found L of x. If we haven't, we can find it now and then replace the x by whatever value we have. Okay. So you can see it's really easy to calculate even a sophisticated format like this. 4e to the negative 0.02 looks really awkward, right? Looks really difficult. And I don't think you can calculate it without the help of any calculator. You can't really hand calculate it. I don't think so. But using this linear approximation, can you see we can actually do hand calculations? It saves much more time than it appeared to be. Any question from this? So your homework question, I guess only 1 or 2 questions might be there, will be pretty similar. Okay. No questions at all? Okay. Then let me show you one more thing before we activation of exam 2. What's that? Anyway, I'll check it later. So I might add one more thing, that can you find the error percentage for me? That means, can you find the error? Now, what's the error? I'll provide you the formula. Error is actually approximation minus the exact value over the exact value. Obviously, it will be positive. I'll provide you the formula. You don't need to remember this. So approximation comes from here. And you can find the exact value using the calculator. Just plug in 4e to the negative 0.02 in the calculator. You will get some value. Can you do it for me? Anyone? What's the value of this? And we can use this to find the error. What's the value of this? 4e to the negative 0.02. Anyone? That should be easy. Okay, use my calculator anyway. But you should be able to find these values because your homework problems will require you to do that. Okay. So it's negative 0.02. So it's actually 3.92079. So I'd write 08. Okay. So it would be 3.9208. 3.9208. So this would be 0.00 3.92, it will be 0.0008 over this. If we divide this by 3.9208, it will give us 0.0002. So that's the error. So if we find the percentage, it would be 2 less, so it would be 0.02%. Okay. Okay, any question from this? Finding the percentage means multiplying it by 100 times this, right? So this is this, and this is your percentage. Okay, I think we're already over time. So